All right, guys. So up at the top, what is the deadline that he has here? 24 hours in order to get the bonus, right? You obviously want to get a bonus. That's a good thing because it means more money in your pocket. So he has 24 hours to do it. That's basically what we get. Oh, and it's 2 truckloads, right? So it's 2 truckloads. So let's keep that in mind. So now going down, right under the picture, it says, due to road construction, Travis knows it will take 10 hours to drive from Pecos to Dallas. The return trip to Pecos will take only 7.5 hours, probably because there's not any construction on that side of the road. So we have 10 hours to get there, 7.5 hours to get back. He estimates it will take an hour and a half to load the truck and an hour to unload the truck. So now it says, why is it impossible? So it tells you it's impossible for Travis to earn the bonus by himself. Okay? So instead of just kind of throwing numbers at me, let's go through the process and make sure we have everything covered. Okay? So starting off, what has to happen?
He has to load the truck.
You have to load the truck, right? So you have to load the truck, which would take hour and a half. So 1.5. And I'm just going to add up all the time. So 1.5 plus. After he loads the truck, what happens? 10-hour drive to Dallas. Once he gets to Dallas, what happens?
Another hour to unload.
Okay, you got to unload the truck, which takes an hour. Plus, what happens next? And you got to drive back, which in this case is 7.5 hours. That would finish one trip, right? So how long would one trip take?
20 hours.
20 hours for one trip. So is it possible? No. Why?
You can double it.
Oh yeah, it's 2 trips, right? Because it's 2 truckloads worth of stuff. So I would say 2 truckloads would take 40 hours. That's why it's impossible for him to get his bonus. He can't possibly make it in, and that's like not even stopping to eat or go to the bathroom or anything, right? Or sleep for that matter. Yes. Okay. All right. So then number 2 says Travis wants to earn a bonus, so he asks his brother Roy if he would help. With Roy's assistance, can they meet the deadline? Yes. How do you know that?
Because they don't have to go back.
Okay, if it's 2 people and 2 truckloads, they can just take one trip, which is 20 hours, and be done, right? All right, so that being said, let's go ahead and look at these 2 specific driving paths. Okay, so let's first focus on Travis. So down below, it says Roy is in Dallas. Remember, they want to take all of the fruit to Dallas. So he's already in Dallas, but he's ready to leave for Pecos. So to meet the deadline and earn the bonus, Travis will leave Pecos first and meet Roy somewhere along the interstate to give him the key for the storage area. So Roy's going to come back to Pecos and pick up the fruit to do the second trailer load. But there's obviously a key to get into the storage facility. So Travis has to meet him along the way to transfer the key. Okay? So I don't get myself confused, I'm going to draw a quick picture. I'm going to call this X over here Pecos. And remember, Pecos is where the food is. Okay? And then O over here is going to be Dallas. All right, who is in Pecos?
Dallas, or Travis.
Travis.
Dallas.
Okay, and remember, Travis is trying to go to Dallas. Who is in Dallas? Roy. And remember, Roy has to come back and meet Travis somewhere along the way and then go to Pecos to pick up the food. Right? So the dilemma is we don't have time to waste. Right? It's a 20-hour trip and it takes and I need to do it in 24 hours or I don't get the bonus. So that being said, in order to accomplish this, I have to make sure to not have one person going, stopping somewhere and waiting. Okay, I need to know where they're going to be meeting. And I can't just say halfway because there's construction going one way, it takes 10 hours, but there's not construction going the other way, it only takes 7.5 hours. All right? So we have a little bit of a dilemma here. We need to be able to solve this, okay? So let's focus on one person at a time, all right? So I want you guys to try 3 together with your partners. It says from Pecos to Dallas, Travis averages 45 miles per hour. If Dallas is 450 miles from Pecos, write an equation that expresses Travis's distance D in miles from Dallas as a function of the hours H. So we'll say D, which is the distance away from Dallas, equals, and I want you guys to finish that. You're going to have to think about things like rate of change, about if he's getting closer to Dallas or further from Dallas, about the initial distance away, different things like that when you're writing your equation. Okay, so take all of those things into consideration and try to write your equation on 3. Go ahead. Okay, so let's work this. All right, so let's think about initial distance, because I'm talking distance away from Dallas. So how far does he start away from Dallas? 450 miles, right? Because he's in Pecos, which is 450 miles away. So 450 miles is his initial distance away from Dallas. As he's traveling, is he getting closer to Dallas or further away from Dallas?
Further. Or wait.
He's going towards it, so he's getting closer.
He's going towards Dallas, so he's getting closer. So should my distance increase or decrease? Decrease. What does that mean in math? Subtract. So I start 450. I need to subtract off of that the way that his distance is changing. So how is his distance changing? It's going down 45 miles per hour. So what does that look like mathematically? 45H, because H is the time since he left. So there's my equation. Okay, so go ahead and take this equation. Let's graph it on the next page. I'll give you about a 20-second head start here. Go ahead. Okay, so I start at 450 miles. And keep in mind, my tick marks look like they're going by 30 here. Okay, so I want to go down 45 miles over 1. It's only down 1.5 tick marks. Down 45 over 1. And remember, well, I guess not remember because I haven't told you this yet. When we're doing systems, it is very, very, very important that you put as many points on the graph as you possibly can. So start getting in the habit of putting as many points on the graph as you possibly can, okay? All right, so there is Travis. Let me just put myself a little key. Travis is red. Okay, so Travis is the red line. Now let's focus on Roy's line, okay? And let's do 5 together here because it's a little tricky to think about. It says Roy leaves Dallas 1/2 hour before Travis leaves Pecos. So if Travis leaves at 5 o'clock, what time does Roy leave? 4:30. So in terms of hours since Travis left, write an expression that represents the time since Roy left, okay? So H is going to be the number of hours since Travis left. What would I have to do to that to get Roy's? Okay, and let me say something really quick to kind of get your mind going in the right direction. So think about it. Put numbers to it. So I said if Travis leaves at 5, what time does Roy leave?
5:30.
What's it say? It says Roy leaves Dallas a half hour before Travis. So if Travis leaves at 5, Roy leaves at 4:30. So let's think about this in terms of time since they left. So if it is now 6 o'clock, how many hours is it since Travis left if he left at 5 o'clock? An hour. If it is now 6 o'clock, how long has it been since Roy left? Hour and a half. So if I'm talking in terms of time since they left, what am I going to have to do to Travis's time? Add 30 minutes. Since we're talking in terms of hours, we need to add 0.5, right? Half an hour. So this is the time since, I didn't work there, Roy left. Okay? So if H plus 0.5 is the time since Roy left, I would like you guys to go ahead and do number 6. Keep in mind, Roy is where right now?
Dallas.
He's in Dallas. So keep that in mind. You have his time. It gives you some information. Go ahead and try number 6 together with your partners. Go ahead. Okay, so again, we're doing distance from Dallas, right? The same D still applies. So distance from Dallas. What is Roy's initial distance from Dallas?
450. Oh, and
Wait. I thought we had this conversation already. Where is Roy?
in Dallas.
He's in Dallas. So what's his initial distance away from Dallas? 0.
Set it up.
Okay, so we start with a big fat 0. How is his distance changing?
It's plus
It's going up, right? Because he's going away from Dallas to go back to Pecos. By how much? 60 miles times Roy's time, right? It's not just 60H, it's 60 times Roy's time, which is H plus 0.5. Because remember, H was Travis's time, so I can't just put 60H. So what is his real equation once we simplify it? D equals 60H plus 30. Okay, so let's go ahead and graph Roy's line, and Roy's going to be in blue. So let's say Roy is blue. All right, so at the time that Travis leaves, Roy is already 30 miles out, right? That's the y-intercept. And then my slope or rate of change is 60 miles per hour. So I go up 60, which is 2 tick marks over 1 hour. Up 2 tick marks over 1 hour. Again, put as many points on there as you can.
I found it.
Okay. Now I want you to take this information and I want you to answer question 8 down at the bottom of the page. Please do not just put numbers. It does ask you for the intersection point. For that, you can put just a regular old ordered pair. That is the easy part of this question. The hard part of this question is answering what that means in the context. Okay? So go ahead and do 8 together with your partners. Go ahead. Okay, what ordered pair did you guys come up with? 4, 270, right? Over and then up. So 4, 270. That would be the point of intersection. What does that mean in context of our problem? Okay, what does that mean in context of the problem? Yep.
And it provides the time that Roy needs to give Travis the keys to the storage tank.
It also provides where, right?
Yeah.
So can you be specific for me?
Um,
So let's start it this way. They should meet.
They should meet 270 miles out from Dallas, 4 hours in drive.
Good. So they should meet 270 miles from Dallas in 4 hours. Okay? So that's that. It gives a specific time and place of where they need to meet. Okay, that's going to be most efficient. They're going to trade the keys. They're going to be able to meet their bonus. Okay? So what are systems of equations good for? If I had a simple question, like how far away would Travis be in 5 hours? A single equation could help me answer that simple question. Or how long would it take, knowing what we know, how long would it take Travis to get to Dallas? If we didn't know that piece of information, we could use a single equation to find that answer. But once we have multiple things happening at once, it gets a little more challenging. Like the questions about if Roy is traveling this fast and Travis is traveling this fast, when will they meet? You guys have heard the classic example of one train leaves this city going this fast, another train leaves this city going this fast. When will they collide? You guys have heard that classic example before, right? That's what this is. It's a system of equations. And then you have to use the system of equations to solve. You have a question?
Yeah.
Okay.
If one of them left earlier than the other, how would they meet in 4 hours? Because technically in 4 hours that'd be
Okay, so I guess 4 hours from, so 8. What does H represent in the problem? Don't just say hours. No, H represents what?
How fast?
It's not just hours.
Hours plus.
How fast?
Hours for who?
Travis.
Hours since Travis left, right? So I guess we would say they should meet 270 miles from Dallas after on Travis's 4th hour. So it would actually be 4 hours after Travis leaves or 4.5 hours after Roy leaves. And that's why we only made H be the time for one person and not the time for both people. So good comment though. Okay. So that being said, systems of equations where we combine more than one equation together helps us to solve more difficult problems. Okay. All right. So go ahead and go back to today's page and pull up the additional notes, which is just kind of a summary of what we've learned. Okay. Okay, so this is kind of a summary of what we just learned. We learned more of a practical application of what we did to kind of discover some of those things. Now let's look at the hard facts and way of doing this, okay? So essentially what you're doing with a system of equations is you are graphing both equations and seeing where they cross. That's real hard, right? I hope not, okay? I want you to go ahead and graph 1, A, and B together with your partners. Find out where they intersect. Go ahead. Okay, so I need to have it in slope-intercept form. It's going to be easiest for us to graph in slope-intercept form. So I'll do one line in each color. So I would subtract 6x, have negative 3y equals 15 minus 6x, and divide by negative 3 on every single piece. Guys, you can see that this stuff didn't go away, right? Slope-intercept form, graphing did not go away. It's still there. Y equals negative 5 plus 2x. Now that I have y by itself, how do I know what is slope and what is y-intercept?
Slope has next.
Good, slope has an x. So m is 2 over 1. B, this is kind of all running together here. B is negative 5. So go ahead and graph that line. Negative 5, slope of up 2 over 1. Again, reminder, make sure you graph as many points as you can, because most of the time, not always, but most of the time, our point of intersection will hopefully be one of those whole number answers. If not, we'll probably just use a different method. Okay, B, I'll do in blue. It already has y by itself, so I can go ahead and identify m is 1 over 1. B is negative 2. So y-intercept of negative 2 up 1 over 1 is my slope. There's where they cross. There's my line. And what is the point where they cross here, guys?
3, 1.
3, 1, right? 3, 1. And just a quick reminder, refresher, all of the points on this red line would be solutions to the red line equation. All of the points on the blue line would be solutions to the blue line equation. I'm looking for the one ordered pair that they both have in common. That is the solution to the system. So the one ordered pair that they both have in common would be the point where they intersect. That's how we find it graphically. We will look at other methods of finding the answer, but for now, graphing is the way we're going to go. Okay? All right, so again, we kind of talked about this when we were over in Springboard, but two or more linear equations together form a system of equations, and any ordered pair that makes both of the equations true is a solution. Okay, and remember that has to make both of the equations true. If it just makes one or the other true, then it's not a solution to the system. It's just a solution to one or the other. Okay? All right, I want you guys to go ahead and try these 1 and 2 together with your partners. Try these 1 and 2 together with your partners. Go ahead. Okay, so you can see my lines for number 1. Red line has a y-intercept of -1, slope of up 2 over 1. Blue line has a y-intercept of -1, up or down 3 over 1 for a slope. Where do they cross? over 0, down 1. So, let me get my pen. So 0, negative 1 would be my point of intersection. That's my answer. Okay, what about 2? Red line has a y-intercept of 2, slope of down 1 over 2. Blue line has a y-intercept of negative 3. I'd be going down 3 and right 1, so I go the opposite direction, up 3 and left 1, so that I make sure and have the correct slope there. Those cross left 2, so negative 2, and up 3, so negative 2 comma 3. Okay, can I get a comfort level on where you're feeling right now? Remember, that's a thumb up, thumb down. I know, I tricked you guys, went back to the 4, 3, 2, 1 thing. Good, okay. All right, so now I want you to look at the 3 problems down at the bottom that say special cases. Remember, special cases are weird, but I'm confident you guys know what to do, so go ahead and graph both lines on each of those problems. Anticipate something weird will happen, but persevere and try to come up with your best explanation for what happened, okay? Go ahead.
Negative X.
Okay, what is the problem on number 1? All right, Ireland.
They don't cross at a point. Well,
That's not true. They cross.
but it's not at a point.
They don't cross it like.
Okay, they don't cross at a whole number, let's say that. Okay, they do cross. There is an answer, it just doesn't cross at a whole number. So, Ireland, what would you say that answer is?
Well, where they cross?
Yep, because that's the answer. Where they cross is the answer.
Like 1.5? I don't know.
Well, it should be an ordered pair, so there should be 2 numbers. All right, so what was the answer you thought, Ireland?
2 and 1.5.
2 comma 1.5. Okay. Drew, what would you say?
2.5 comma 1.5.
2.5, 1.5.
Okay.
I mean, it's hard to say honestly. Okay, because you have to think about also. Okay, I'm a human trying to draw a straight line through these points. I am trying to look at it and eyeball where I think it is. Okay, it's not going to be exact. So this isn't necessarily a special case, but I put it here just to kind of show and make you aware that graphing is not always the best way to find an exact answer to a system. It works wonderfully if we have a nice whole number answer, but as you know, in real life, everything's not a nice whole number answer. Okay? All right, so that being said, difficult to find answers from time to time. What's up with 2?
Parallel.
Why do you say parallel? How do you know they're parallel?
Because they never intersect.
Okay, they never cross. What is a better way of knowing that they're parallel?
Same slope.
I was close.
What'd you say?
Same slope.
Same slope, right? They both have a slope of 2. So what I don't want you to do is fall into this trap, and let me just show you this. If I have this graph, here's line 1, here's line 2. Oh, well, Mr. Craw, they're parallel because they don't touch on my graph. This is no solution. That's not true. Just because they don't touch on your graph doesn't mean at some point they won't touch. You have to verify it and make sure that they have the same slope, just like our problems here on number 2 do. Those have the same slope. Those are parallel. They never touch. So what would be the point of intersection here?
No solution.
There you go. They don't cross, so our answer here would be no solution. You remember that special case? Question? Yes, sir?
So on a test, if we graphed it wrong, but we still got no solution, would you take off?
It's actually kind of doubly wrong. Because if you graphed it wrong, then it shouldn't be no solution, because at some point they will cross. Unless you still graph 2 parallel lines, but you just did like the wrong y-intercept or something.
If you graphed two parallel lines, they're just in the wrong spot.
Yeah, I mean, you'd still lose some points because you didn't graph right, but okay. Anyways, so no solution. Okay, number 3, what's up with those?
I don't understand that one. That's crazy.
Okay, well, when I solve both of them, do you notice that you get y equals x minus 2? Or y equals negative 2 plus x, either way? They're the same exact line, right? So if it's the same exact line, what is the point of intersection?
All real numbers.
You're close. because we're talking ordered pairs, so it's not just all real numbers.
All real.
But there's a whole bunch of them, right? So we call it infinitely many solutions. Okay, so we have the regular case where they cross at just a single point. There's just a single ordered pair answer there. We have parallel lines where they never touch, which would be no solution. And then we have where they are the two exact same lines, where they would share all the points. That would be infinitely many solutions.
Can we shorten that?
What?
Can we shorten that?
IMS. Yeah. Okay, questions? Alrighty, the rest of the time is yours for homework.